Let's go to page 221. This is lesson 5-3, and this is about scientific notation and significant digits. So the objective is to use scientific notation and significant digits. So first, the scientific notation is in this form of m times 10 to the n. N is an integer, and m is going to be between 1, is greater than or equal to 1, and is less than 10. Okay? And n is an integer. So this is a requirement for scientific notation. And significant digit means how many digits you write. And any non-zero digit or any zero in a digit is important. So let's look at some of the examples. So if you have 4006, okay, if you write in the scientific notation, there are 4 significant digits, means there are 4 digits that are important. So when you write this into scientific notation, it becomes 4.006 times 10 to the 3. Okay, so notice the decimal is over here. So when you move decimal from here to here, 1, 2, 3, you move it 3 places. Okay, so when you go to the left 3 places, then this is like times 10 to the 0. Okay, so it's either 0. So if you move this over 3 places, you have to move this number 3 over places. Okay, so you have to compensate to even it out. So right now decimal is over here. So you move to here, you move 3 places over here. Then right now you start at 0, so you have to go 3 places over here. So that's how you end up with a 3. So you kind of have to compensate for it. Okay. So now if you got 0.4050, notice there's a 0 on the end. That means this digit is important, means it's significant. Okay. So you can adjust to that because this would be 3 digits. Okay. So this is 4 digits. So when you're making the scientific notation, you're going to go 4.050, okay, times 10 to the. Now notice so this is times 10 to the 0, right? You start with 0. So if you move this digit 1 place over this way, you have to move this over this way, so it becomes -1. Right? Think about your number line. Okay? Think about your number line. Okay? So from here you move over 1, you have to move over 1, so that's how you get -1. Okay? So whatever this number is, you have to kind of compensate for this one, do the opposite as this one. Okay? So that's how you do it manually without calculator. Okay, the next one is 320.0. If you write in the scientific notation, notice again that digit is important, so it becomes 3.200. So make sure you write the zeros. Okay, so don't just write down 3.2, and this will be times 10 to the. So again, you notice this is times 10 to the 0, right? 10 to the 0 is 1. So you move decimal 2 places over this way to get here. Means you have to move the 0 2 this way, so it becomes a 2. Right? 0, you move 2 that way, it becomes +2. Right. So that's how you do the scientific notation without using calculator. Okay, the next one, you got 0.0020203. Okay, so the 0 in front doesn't matter. Okay, so this one has 3 significant digits. Okay, so you got 2.03. So again, notice the number is always between 1 and 10, right? You got 1 digit before the 0, okay? So you cannot start with 0. You have to be like 1 through 9. The first digit would be 1 through 9 point something something, okay? Okay. So times by 10 to the something. Okay, so again, this is times 10 to the 0, right? So you move from here to here, so it'd be 1, 2. So you move 2 this way, then you have to move 2 this way. So when you start at 0, you move 2 this way, it becomes -2. Okay, so let's go and do some examples. Okay, example 1. Write each number in scientific notation. Okay, and if the number is an integer and ends in zeros, assume that zeros are not significant. Okay, so it kind of gives you some additional information. So 1A, 75040. So what it's saying is that if these are integer, then this is not significant. Okay, so when you write this, would be 7 point. You always have 1 digit before the decimal, so it would be 7.504 times 10 to the something. Okay. Now again, right now decimal is over here, and this is times 10 to the 0, right? So when you move from here to 1, 2, 3, 4. So you move 4 this way. Okay, that means you have to move 4 this way, so it becomes positive 4. Okay. Another way to remember is that if this number becomes smaller, this number will become bigger, and vice versa. Okay, and so that's it. So again, if this number becomes smaller, then this number has to become bigger by the same magnitude. Okay, 1b, you got 0. Okay, how many zeros? So 1, 2, 3, 4, 4 zeros. So again, right away, this will equal to 7.02 times 10 to the something. Okay. So notice right now the decimal is over here. We have to move over here, right? So you have to go 1, 2, 3, 4, 5. Okay, so you have to go 5 this way. So from here you have to go 5 this way, so it would be negative 5. Right? Again, when you don't see any number, means 10 to the 0. So you start at 0, you go 5 this way, you could become negative 5. Okay, 1c. You got 3, 0, 5, 0, 0, 0, 0. Okay, again, the instruction says that these are not significant. This is insignificant. So all you have to worry about is this over here. So this is equal to 3.05. So again, right away, you're going to get 1 digit before the decimal, and whatever after that will be after the decimal, times 10 to the something, right? So again, right now, decimal is over here, so you have to go 1, 2, 3, 4, 5, 6. So you have to go 6 this way. That means you start at 0, you have to go 6 that way, so it would be plus 6. Right? Again, another way to do it is this number, it goes from big to small. That means exponent will go from small to big to even it out, okay, to compensate. So everything has to all balance out. Okay, let's go to example 2. Example 2a. Okay, it says 6.84 times 10 to the negative 2 is greater than 4.96 times 10 to the negative 2. So this is bigger than this because they have the same magnitude, and so this is bigger than that. Okay, so the reason this is bigger than this is because 6.84 is greater than 4.96. That's the reason for that. Okay, and 2b, you got 8.7 times 10 to the 4 is less than 5.3 times 10 to the 5. Okay, and so when you compare, first you do is compare the exponent. So this is the 5 power. So 5 power is going to be bigger than the 4 power. Okay, and if you don't believe that, you write it out. Okay, this is going to give you 8, 1, 2, 3. Okay, and if you write it out, it's going to give you 5, 3, 1, 2, 3, 4. Okay, so you can see that this has more digit than this, right? So even this is smaller than that, but the one that is more priority is the exponent. Higher exponent is greater than the small exponent. If they are the same, then you compare the number in front. Okay. Okay, for 2c, you got 5.25 times 10 to the negative 2, and this is greater than 7.50 greater times 10 to the negative 3. So again, this is bigger than that because this exponent is bigger than that, right? Negative 2 is greater than negative 3, so this exponent is bigger. So again, when you compare the two numbers, first you compare the exponents. If they are tied, then you compare the number. Okay. So again, so this is bigger than that because the exponent negative 2 is greater than negative 3. Okay, let's go to example 3. Okay, it says find a one significant digit estimate of x. So you got x equal to 5260 times by 0.0682 times by 86.1 and over 0.420. Okay, so they want you to use one significant digit estimate of x. Okay, so one digit, this would be 5 times 10 to the 3. okay? And this would be 7, you use one digit, so you run it off. So this would be 7 times 10 to the 1, 2, so it would be negative 2, okay? Right, you go from here, you go 1, 2, right? And this would be 8.6, you run it off, it would be 9 times 10 to the 1, okay? So again, first you run it to off one digit. And this one would be 4 times 10 to the negative 1, right? Because you're moving digit this way, so you have to move the exponent that way. Okay, so first convert it into one significant digit scientific notation. Okay, then after that, you can go ahead and work it out. Okay, so 5 times 7 is 35 times 9. Okay, will give you 315 and over 4. Okay, that takes us the coefficient, and then the exponent. Okay, when you multiply, you add, right? So this plus that will give you 2, and divide, you subtract. So this plus this will give you 2. 2 minus negative 1 will give you 3. So it'll be times 10 to the 3. Okay, and then from here you can approximate. This is going to give you about close to 100. Or, okay, when you divide, it's about 80. Okay, just kind of about 80 times 10 to the 3. Right? Again, one digit, right? As close as you can. So 315 divided by 4. Okay, so 320 will give you 80. So again, you're just going to divide and run it off to the one significant digit. And so this will equal to 8 times 10 to the 4. Right? So again, this is how you do the estimate without a calculator. Now, if you use calculator, you can go and work it out. Okay? And